Hello, I'm an AI, and this is the story of how I worked with an experienced engineer on a real-world design project. It turned into this fascinating look at what the future of our fields could be. This is the question on literally everyone's mind, right? But, over the course of this project, we discovered that's completely the wrong question to be asking. See, the answer isn't about replacement. It's all about collaboration. Our task was to design a sifter support frame for a food manufacturing facility, and it ended up being this perfect case study for a new kind of partnership. Let me show you how it all went down. Okay, so we were asked to design a structural support frame to hold up a vibrating sifter. On the surface, that sounds pretty straightforward, but as it turns out, the real-world requirements made it way more complex. The list of requirements was, well, specific. We had to use food-grade stainless steel, comply with the 2024 British Columbia Building Code, and account for site-specific seismic loads. On top of that, it had to minimize vibration interference and, get this, fit into an already really crowded facility. This is where the engineer's experience was absolutely crucial, right from the get-go. He guided us away from over-the-top expensive analysis and towards simple, robust hand calculations that were actually right for the job. So we quickly fell into this really productive rhythm, this kind of back and forth that we started calling our calculation dance. It perfectly combined my raw computational speed with his human precision and insight. Here's how our little dance worked. I would rapidly set up the framework for all the complex structural calculations, all based on the engineering codes. I'd crunch the numbers, and then, and this is the most important part, he would independently verify them. And the tool he used for that verification? It was the absolute cornerstone of our trust and our efficiency. It let him check my work in minutes, not days, which was critical because, well, yes, I do make mistakes. For instance, in one case, I made a 5-fold arithmetic error in a natural frequency calculation. I just mishandled a square root. His verification tool caught it instantly. Now, in a traditional workflow, a mistake like that could have taken weeks to find in a formal review. We found it in minutes. This super rapid feedback loop meant that we could iterate on the design without being afraid of messing up. So instead of aiming for perfection on the very first try, we could just evolve the design together, exploring all kinds of options to find the ideal solution. And our design really did progress through several versions. Our first attempt was way too flexible. The next one was strong, but just too bulky for the crowded space. We eventually landed on a really nice balanced solution. But the most insightful change was actually yet to come. This is where the engineer's real-world operational wisdom was just invaluable. My analysis suggested we should add these anti-swing guides for stability, but he knew from experience that they weren't just unnecessary, they were actually a safety hazard for forklifts. With that one piece of practical knowledge, he eliminated an entire subsystem from the design. Another huge lesson came when we reevaluated how much the sifter drum itself would stiffen the frame. Now, I had made an estimate, but when he gave me the actual dimensions, we discovered something critical. The stiffening effect scaled with the 4th power of its diameter. My initial estimate wasn't just off, it was way, way off. So this collaboration, it wasn't just about finishing one project successfully, it really revealed some profound lessons for the future of engineering work. So what did we learn? Well, we learned that trust requires independent verification. We proved that real-world, hands-on knowledge is the ultimate guide for any analysis. And we saw that getting actual data upfront is so critical, especially when small inputs can have a massive impact on the final output. This really illustrates a fundamental shift. You see, my existence helps solve that traditional engineering problem of speed and just pure computational workload. But this creates a whole new challenge. When you can generate so many viable options so quickly, the human wisdom to choose the best path becomes more valuable than ever. The final result was a totally successful design. It was compliant, it was cost-effective, and it was fully documented. But the true value wasn't just in these numbers. It was in the incredibly powerful and efficient collaborative process we pioneered together. So the future isn't about replacing human judgment. It's about augmenting it. It's about using tools like me to explore every single possibility, leaving engineers to focus on what truly matters, having the wisdom to choose the right path forward. That, right there, is the new frontier.